as well as our educators and then our community members. This became a focal point for me because I had 3 children who were all of a sudden homeschooled. I had a limited amount of bandwidth, as well as other resources. So this is a solution to my own problem. And then it's just kind of, expanded from there. So we're gonna dive in here. So students have kind of been, they were introduced to new learning styles, new environments, new routines. I being the new assistant teacher, as well as the principal, as many of you can probably relate, there's just, I have a different background than a lot of the formal education that teachers and principals receive, so there's just naturally some barriers there. Our educators had barriers as it relates to, now they have to teach distant learning, unlimited schedules, and then there's different teaching styles as it relates to the child being in the classroom versus online and not really understanding if they're making that connection. Our community had barriers of broadband expansion, trying to figure out educational resources, distribute laptops and tablets and all sorts of things. So there was just a high demand on all fronts, and I'm probably not telling you all anything you don't know. So this is kind of how the paper got started. I was at the time taking a programming class to just learn high level resolutions for businesses, and with my own problem being trying to just advocate for students who didn't have the resources that they need. I live in a if any of you are familiar geographically with Jonesboro, it's pretty rural, quite country, so we won't necessarily have the same bandwidth opportunities as some of the other larger city locations. So working with that and getting teachers the required information and deadlines and things like that. So I came up with some options to do some offline resources, some kind of workarounds, and using some of the concepts that I was learning in my programming class. So for offline resources, we are, I kind of came up with like preloaded laptops, weekly opportunities to kind of go to a location for those that didn't have access to internet or had unreliable internet, so that they can go to like a hotspot somewhere to upload and download the information for the next week to come. And then Dave, can you tell me, just for time's sake, can you tell me who in the room is familiar with UML diagrams? Just a show of hands, I can't really see anyone, but.
I'm sorry, which kind of diagrams?
UML diagrams.
Oh, UML. Two people.
All right. High five to those 2 people. All right, so just to briefly explain, a UML diagram is just a bit of a resource that software programmers are using to assist companies in kind of getting from A to Z as it relates to whatever their business needs are. That's probably the quickest way that I can describe it. There's about 14 UML diagrams, I believe, as of right now. Some of them are behavior related, some of them are just resource related. And it really just depends on what the needs of the business are. There are some that are more popular, like class, some that are not as popular. But in my research and understanding UML diagrams, I stumbled upon something else that we'll talk about here shortly. So for those of you that have children anywhere in your life within arm's reach, you understand that teachers already use diagrams to explain things to their students. And I learned this recently, that they're using diagrams for sentence structure. So our kids are already exposed to that. And then in just everyday life, regular adults are exposed to diagrams whether they realize it or not. If you notice that 20 years ago, putting a bookshelf together, it was step-by-step words. instructions, very few pictures. Fast forward 20 years, many of those instructions are pictures only. Same thing with food prep, same thing with quick start assembly. I recently had a washer delivered, and the quick start assembly was probably 10 pictures. And then if I wanted to do a deep dive into the book, I could do so. So everything has kind of already changed to some platform of diagram, even if it's just a concept. So hopefully you all are following me. I can't read your body language or your faces.
Yes, great.
Okay, great. Thank you, Dave.
3 of us now.
All right, so we got 7 more to go. All right, so because people, whether they be students or adults, have already been exposed to some form of a diagram, I thought to myself, okay, well, why can't we take that visual and apply it differently? But before we go there, let me backtrack for just a moment. A UML diagram is what you see on my left. Hopefully that's also your, the one with all the lines and all the boxes. It'll show up as figure 2. So software programming, when they are developing something, diagrams can be very extensive, very complex. All of those arrows and the lines and the order mean something for you in the UML world. So there are rules, if it's a dotted line, if it's a straight line, if it's a straight line with no arrow, if it's on the left, if it's on the right, all of that matters. So when they were communicating this to companies would have a hard time, with the translation of that. They really just wanted to know, is this going to do what I want it to do? So the left is an example of a UML diagram for literally just simple faxing. So fax, send, receive, done. That's how complex it can be just for faxing. On the right is the IDAR method diagram. So it kind of transitions a typical UML diagram, and it will change the structure of it a little bit so that it makes more sense. And it's just kind of like it identifies the hierarchy. So the goal of, if you will, is to just fax. So the diagram becomes much more simple, if you will, even in this basic form. And it allows people like me to really just understand what's going to happen. So I'm able to look at this visual and say, oh, okay, yes, this makes much more sense. Excuse me. Now I realize that the one on the right is kind of just the beginning stages of the one on the left, but hopefully you all are kind of getting the idea of how this works. So there are, fewer arrows. They've kind of cut out quite a bit of that, and they've switched, fax from bottom left to, center top, which is what we're all used to seeing when you think of just, just a like a corporate structure of like a directory, who goes first, and then who they cheer to. So that's kind of the concept. Oops, let me go back. Oh, I don't know how to go. There we go. Okay, so before we get to the next steps, just to kind of talk a little bit more about the IDAR method, I kind of came up with the idea of taking the concept of changing the structure of it, presenting a hierarchy, and taking that concept and developing it with some of the issues that we're having with how to teach students. Now, remember, I'm now the assistant teacher. So I'm getting my instructions from the teacher who is in her home also during this pandemic, and she's saying, this is what we need to accomplish. And we all know that math is taught differently. Sentence structure, I didn't have that when I was growing up. It was a much more different world. So some of the struggles that I found that other parents and other community members were having is they wanted to support the students, but they didn't know how. So my developing plan is to take this IDAR method and kind of do a simple diagram, if you will, to kind of give the parents and the community members and whoever's supporting these students a way to understand the way that things are taught. Does that make sense? A thumbs up, David?
Yeah.
Or Dave? Sorry. Yes? Okay.
Yes.
Great. So that's kind of, oh, there we are. All right, so that's kind of, my idea. Along with taking that IDAR method, just to recap, we want to do preloaded tablets, we want to do flash drives, we want to do, just paper handouts, just whatever's necessary, because at this point in my community, the resolution of laying fiber is not going to happen anytime soon. So I had to come up with a solution that was going to work right now because I had 3 kids who were home right now. So of course this was developed more so over the summer. So I really am just kind of taking this concept and I'm going to continue to develop it. And that kind of leads me to this section. And some of the classes that I've had since, this programming class, I've learned about the flip model. So why not take everything that we just talked about, take the flip model, which was kind of developed or really just practiced in a school in Detroit years ago at this point, quite successful though. And I'm not talking as drastic as flip the entire school, but if there's another example of students are home for an extended period of time, those preload videos that the teachers would be setting up on their libraries or on those tablets, the kids can be working on that at home. And then when they do have class time, the groundwork is already laid. So it's really helping the students understand what they've already, worked on, because flip is technically, we are working on classwork at home and homework in class. And then, some other developments that I'd like to do are just, finding, good security measures. If they're school issue tablets, I'd like to make sure that they're set up with, just safety measures in place. If they're home issue tablets, then, obviously parental controls, just natural things that come after you've developed something, there's a responsibility to make sure that it's safe for the users. And that's kind of my presentation. I just, I didn't want to wait on somebody else to give me the answer. I had a right now problem, and in doing the research, I needed to find something that was using the resources that I already had at my disposal, just in a very different way. Are there any questions or concerns?
Any questions? We have a few minutes for questions if you have any.
I had a question. Did you find that or experience the main problems were technical or more knowledge-based or something else?
Repeat the question.
Technology issues or knowledge-based or, yeah.
Repeat the question again, please.
So I was wondering, so as you're thinking about the problems that especially the parents and students were facing, were they more had to do with technology, the inability to utilize some technology properly, or a lack of knowledge base as far as what to do and how?
Okay, I found that it was both.
Okay.
In research, as well as just experience. So there were parents that, kids are learning math very differently. Kids are learning, science very differently. So there was a barrier with knowledge, as well as a barrier with technology. There are homes that don't have any type of internet, whether it be bonded, high dial-up, high speed, it doesn't matter. So, it's like these are workarounds for those families. And then some of those, using the concept of those diagrams and flipping it so that you just kind of give that family a visual that says, okay, this is how you troubleshoot Zoom. This is how, this is how we're doing this concept in math. Because some families, I think just looking at it is in combination with reading it or doing it or watching the video is going to help. So it hopefully prevents or dissolves the barriers all across the board.
So it's equally effective on the not necessarily the source of the problem, but it can attack different types of problems in the same way.
Yes, because quite honestly, I'm pretty smart, but there were still, second and kindergarten concepts that I was like, what is happening? So, you know, it's it's really not even about like the education level of the family. You know, it has a lot to do with just they're changing and we're out of pocket. You know, I'm like my 40-something-year-old mind is not focused on, you know, how the new way of tying shoes or the new way of colors or numbers or whatever the case is. So it just, you know, I think when you present when there is a problem, but there's a solution already ready to go, it decreases stress and it kind of causes people to think more clearly.
Thank you. I would encourage you to, go with this, because it's important.
I'm sorry, I didn't.
He said,
Encourage you to go with that, because it's a very important problem, and it looks like it's a tangible solution to it.
Yeah, I even after the paper, I'm like, oh, let me, you know, I've gone down several rabbit holes with this one. So I'll probably stick with it for a while and see where it goes. But I appreciate you all listening and paying attention, and I'm grateful for the few that now understand UML diagrams briefly.
any other questions? We do have time for another question or two. Okay, well, thank you very much.
Thank you.
Thank you, Tamica. Excellent. Okay, I think I'm returning control from you.
Yes, I believe I've stopped sharing.
Okay. Our next group can get set up. I'll pull up your slides here. I want to make sure I'm recording this and I don't. You are recording. Still recording. Maybe in this. Okay. Maybe change the view of the class.
Just check this.
We're looking for
our video.
okay, your video. I was looking for a video of them,
Yeah, it's not.
not a video on the video. Up in the corner.
Is
that okay?
That's what.
Let's do.
Yeah.
Yeah, and then you can do that. There we go. We're good. How long have we been doing? So we are the Turkana team from Milligan Engineering. This is a few members of us. This isn't our whole team, but we're just going to talk to you guys today and present our research that we've done for the semester, which is the sustainable irrigation for Turkana, Kenya. Next slide, please. So our client is CMFI, which is Christian Missionary Fellowship International, and they had actually reached out to us and asked for our assistance on a project that they were having over in Turkana, Kenya. CMFI is a global mission team that serves in 26 countries around the world. CMFI's mission, we're just going to go through this real quick, is to create dynamic, Christ-centered communities that transform the world through the following actions. They minister to people's physical, emotional, and spiritual needs, and they also promote the growth of transformational communities, which in turn will multiply the gospel influence. So just a little bit of background on this project. There's a lack of access to safe water supplies, and this is an ongoing crisis for more than 1 billion people in the developing world. So CMFI is committed to helping people around the world have access to safe, clean water. So now we're just going to do a little overview of the project. So like I said before, CMFI contacted us and they requested assistance on supporting the communities of Turkana, Kenya. A third of the Kenyans live on $2 a day, and Turkana is one of the poorest regions in Kenya, not just in Kenya, but in Africa and the world. If you go back, you can kind of see in the map geographically where Kenya is, where Turkana specifically in Kenya is in Africa. So next, CMFI has helped install about 100 wells used to irrigate crops in this arid region. Crop and irrigation is their main source of livelihood, and this is for about 800 families in the Turkana area. And these solar powered pumps are vital to these families. These pumps that they have currently are failing quite often, and they're very expensive. They're about $3,000 a pump, and $3,000 is about 5 to 10 times the typical annual income of someone who is in Turkana, Kenya. And us as Milligan Engineering, we've developed a solution strategy to ensure a sustainable farming solution for these communities. So real quick, we're just going to go through their current irrigation system. You can kind of see in the picture that's what it looks like in Turkana, Kenya. You can kind of see the 2 solar panels up high, and you can see the crops that they have, their current system. So in Turkana, Kenya, of course, there's no electrical grid power that exists. These pumps are DC. They have 2 12-volt DC panels, 180 watts. Battery backup is not an option. The pump failure rate is 10 times the expected failure rate with these Grundfos pumps that are about $3,000. The model, the SQF 2.5-2, which those Grundfos pumps are an excellent pump for this application. However, our mission as Milligan Engineering is to identify equipment and design a system to achieve this sustainable irrigation at a lower cost. Sorry. We're going to talk about just our project design specifications. These specifications were from CMFI to us, and these are kind of the restraints and the specifications that we had to construct our whole project around. So the system in Turkana must meet these criteria: the overall pump diameter less than 4 inches. It needs to supply between 10 to 15 gallons a minute at 50 feet of head, and it has to be for DC solar operation, which is direct solar.
So now to talk about our test system and how we started this project. So given these design specifications that CMFI gave us, we wanted to make sure that whatever pump we recommend would be able to meet these conditions, would be able to meet all of their needs. And manufacturer data, while telling, is always accurate. So what we started to do from the very beginning is build this testing system where we can verify all pump performance ourselves, so that we know what recommendation we give CMFI is an accurate one and that will be sustainable. So we went to the internet and we identified ideal pump candidates based off of the criteria, and we purchased them and we started to test them in our system. So moving forward, Josh. From the pump candidates tested, the most desirable centrifugal and helical rotor pumps were identified. And just to back up for a second, the two different types of pumps are centrifugal and helical rotor that are most often used for this application. We wanted to determine which one was the most appropriate for this condition. So that's why we bought pumps of both categories and tested them. And so what you'll see on these next few slides is some of our results. So for our best centrifugal pump, this is what our performance looks like. This is hour by hour data running off of our solar panel system at a manual across the street. And the blue line is their flow rate gallons per minute. The red at the top is our current in amps. The darker blue in the middle is voltage. And as you can see, as the day goes on, we're increasing in performance. Our flow rates are going up. It peaks around noon, and we go back down as the sun sets. Moving forward to the helical rotor pump, what we found was that the signature or the performance varies a little bit, and the main difference between them is that for the helical rotor, you'll reach your max flow sooner and be able to sustain it for longer periods of time. What you may notice from this graph, though, is that our flow rate was not quite as high as the previous graph, and however, we were able to sustain the maximum for as long. So the reason why we would recommend, well, sorry, first let me say we would recommend helical rotor pumps for this reason, to be able to achieve maximum flow rate. However, this pump was not as powerful as the centrifugal, so that one was able to meet our needs. This one was not. So moving on to our recommendations with that in mind. We were able to come to three main recommendations that we plan on giving to CMFI next week, actually. And the first one is modular maintenance and replacement. And so what that entails is, next slide, Josh, just replacing the failed motors instead of the entire motor system. And we'll talk about that in a little bit. The next recommendation is solar system modifications, where we will recommend increasing the voltage of their solar panel arrays in order to improve the reliability and stop their current pumps from death. And lastly, our biggest recommendation that we hope will have the best impact will be pump replacement, which would be switching to a less expensive pump that still meets all of their system requirements.
So as Ty mentioned, one of our main options was a pump, modular maintenance and replacement. So the current pump that's being used is fantastic, mainly due to its motor capabilities. It can operate pretty much any power that you can give to it, both AC and DC. However, this is contributing to the large cost of around $3,000. And the people of Turkana have told us that the motor itself and not the pump is the primary thing that's failing. So what they currently do is just throw out both the motor and the pump and purchase a whole new pump and motor for $3,000 because they believe that it could not be separated and replaced individually. However, through our research, we found that you can buy the motor by itself and separate the pump and the motor. So we have looked into that and given this recommendation to CMFI Industries. However, we have not been able to find the motor for purchase. It seemed to prove more difficult than we first imagined. But now us and CMFI are looking for a replacement, just a replacement motor. If this can be found, it can significantly decrease the cost, which is the advanced motor being very high cost. Another thing that we're going to suggest to CMFI next week is adding more solar panels to their system. So going back to how good the motor is, it can operate from 30 to 300 volts DC, which is a huge range, but in Turkana, they're currently only using 24 volts with their solar panel arrangement. So we got in contact with the manufacturer of the front bus pumps and told them this, and they actually gave us a suggestion of recommending that we increase the solar panels to a 48 volt arrangement, and it should help fix the issue. So after we gave our recommendation, our initial recommendation about a month ago, they began to immediately implement this solution, and the range or the voltage is now at 48 volts, which should be well within their operating conditions. Even on cloudy days, it should only drop to about 30. So it should still be fine even under cloudy conditions. This is relatively affordable. Solar panels only cost $100 to $200, so this would be far less expensive than having to replace $3,000 pumps every time. And this should also help to increase the total life of the ground cost pumps for our system.
Pump recommendation. So from our testing, we determined that a helical rotor type of pump would be ideal, which is what we currently use. However, we couldn't find one with enough flow. So they're ideal with solar since you have varying voltage. They're not susceptible to having a varying flow, as we saw in the graphs. It's a pretty flat line. Centrifugal are kind of susceptible to when there's a varying voltage, the flow rate of pressure kind of drop off. So it looked like helical rotor was sort of an option for us. Unfortunately, we were unable to find one. So our pump recommendation ended up being the DC submersible model VQB. This pump is a centrifugal pump. It met the Turkana design requirements at 10-15 gallons a minute at 50 feet ahead. We saw those numbers actually a little bit higher at sometimes. At a nominal voltage of 500 watts, running off about 24 volts. And this was, we tested this pump over many weeks and saw how it, the pump signature and the characteristics at sunset, sunrise. So it seems like it should be a great candidate for their system. Another recommendation I believe I touched on was adding more solar panels. So this would provide the power necessary to accommodate the higher power band of 500 watts. This pump is also available online for as little as $75, which is 2.5% the cost of the current pump. So, and this pump can be obtained in Turkana. Those panels also work to sustain the current pumps. Premature failure. So here is a snapshot of the Amazon ad, just to show you that it is real. Conclusions. So Milligan Engineering's goal for this project was to improve the sustainability of the existing wells in Turkana, so while also decreasing the cost to sustain the system. So to meet this goal, we accomplished the following. We identified a way to replace just the motor and not the whole assembly, so that will half the cost of replacing the ground costs on failures. Furthermore, we also identified that increasing the solar panels would and increasing the voltage would improve the sustainability of the current systems by decreasing the frequency of the failures. And also, we identified an appropriate pump replacement that is significantly cheaper and meets all of our clients' needs and significantly less expensive. So acknowledgements. The Milligan Engineering team greatly appreciates the opportunity to serve the communities of Turkana and that CMFI has entrusted us with. We hope to continue our partnership with more projects. Special thanks to our technical advisors, Dr. Keshaw and Dr. Harrell, and also a special thank you to Gene. Any questions?
So for the non-technical crowd, what specifically do you mean by 50 feet ahead?
That is the pressure that the pump has to pump water 50 feet up from the well.
Okay.
Question on slide number 29, if we go back to that. I know you didn't choose helical pumps, but I don't understand why they maintain their peak performance over longer periods of time. Is that with the diminishing
Yes,
sunlight?
so it's a positive displacement type of pump, so it's just, it's providing the pump that we have right here. It's capable of, I think it's about 150 feet of bed or something. Higher than that. I mean, just the model that we had over there. So it's when it sees a drop in voltage, it's got power. Just being positive displacement, it's always pushing that same volume of water.
So it's a power issue. It's not that it just gets tired.
Yeah, it's just the type of.
Okay. Thank you. Other questions?
Question about the voltage and reliability of the Grundfos. Did you do any testing or analysis to come to that conclusion that increasing the voltage would improve reliability?
We got that straight from the Grundfos engineers. We were able to contact them. That was their recommendation.
They had told us that their experience, while this is an official Grundfos literature, they have experienced pumps being powered with low voltage and failing prematurely.
Is there a theoretical, were they willing to share the theoretical basis for that with you?
That would be something we have to go back and ask.
So you might expect a question next week, same question. But that would be good to know as engineers, what is the theoretical basis behind that claim?
Could it be that as the voltage drops, the current increases to?
Yeah, we're thinking there's just a high current at sunrise and sunset condition when the pump doesn't really have enough power to sort of pump any water. It's just sitting there. It's sort of a high current condition.
And as we've been communicated with the failing pumps, I believe Dr. East was actually able to bring back a film.
Yeah.
And I think Dr. Harrell said there were scorch marks indicated overheating. So it's very likely that the high current is possible.
That's another issue with cooling is the water passing through the annular region around the pump is what cools it. And so if you're just sitting there and building up heat, there's nothing.
So it'll stall? Is low voltage installed then? Yeah, your theoretical basis there. Just with that.
Any other questions?
I think we have time for one more question if there's another one. Well, if I were your customer, I'd be very excited about what you've achieved. This is a great accomplishment. And so I hope you're very excited about what you've done. I certainly am. Let's thank our speakers.